Okay, so yesterday we talked about how to go from moles to mass and mass to moles. Today, just to show you an analogy, let's say that you knew that in 1 dozen jelly beans, there was 35 grams. So you knew that the mass of 1 dozen jelly beans is 35 grams. And let's say you wanted 5 dozen jelly beans. Well, if we know that 1 dozen weighs 35 grams, you can multiply 5 times 35, and that would tell you how much 5 dozen jelly beans would weigh. So instead of counting out 60 jelly beans, you could just weigh out 175 grams of jelly beans, and you'd be confident that you have 60 jelly beans. So that's similar to what we were doing with moles yesterday. You can think of it like this, 5 dozen, it's similar to what we think of as a mole. It stands for a number. So we could say 5 moles of carbon, and we multiply that by carbon's molar mass. So remember, look at the periodic table, look up carbon. There's a 6 on top, 12.01 on the bottom. So the 12.01 tells us that 1 mole of carbon weighs 12.01 grams. So we put 12.01 grams here. That's in 1 mole. Multiply it out, we get 60.05 grams in 5 moles of carbon. So it's the same setup, so in everyday life we would use something like this. So it's not different than what we've done before. It's just moles, we're not used to using that term, but treat it like a dozen, use the same kind of conversion, and that might help with this. Do you all have that down? Okay, go ahead and erase that. So let's say that you had 550 grams of jelly beans, and you want to know how many jelly beans you have. So we said that 35 grams equals 1 dozen. So our unit multiplier would look like this. In 35 grams, there are 1 dozen jelly beans. So you do 550 divided by 35. That would give us 16 dozen. Now it's more useful though to know how many that actually is. So we would multiply this by 12. To get how many that actually is. That's 192. So that's a jelly bean example. We'll use the same thing with atoms. So using the carbon example again, let's say we have 550 grams of carbon, and we want to know how many atoms that is. So we'll do the same thing we did up here, but instead of a dozen, we're going to divide it by 12, because we know that there are 12.01 grams in 1 mole of carbon. So this will cancel out grams, we get moles. So 550 divided by 12.01 would give us the moles of carbon. And that would equal 45.8. Now with sig figs, that should be 46, because this gives us 2 sig figs right here. And actually, same thing up here. This actually should be 190. because this only has 2 sig figs. So in both cases, you'd have 2 sig figs. So 46 moles of carbon. But the question is, how many atoms are there? So we have to have one more step. In 1 mole, we know it's Avogadro's number of particles, 6.02 times 10 to the 23rd. So we would multiply the number of moles times Avogadro's number, and that would give us the answer in moles. Sorry, the answer in atoms. 46 times 6.02. So that would give us 2.8 times 10 to the 25th. So that's how many atoms you'd have in this sample of carbon. Does that make sense to everybody? Any questions about that before we go on? All right, so that's it for the lesson today. I did want to tell you about the pie answer the other day. So I asked you 2 days back, if you were to take a pie and it has 1 mole of sugar in it, so it has 6.02 times 10 to the 23rd sugar atoms in it, sugar molecules in it. And the question is, how many cuts would you need to make to the pie to get down to 1 atom or 1 molecule? And the answer is 79 times. So you need to cut the pie in half, and half, and half, and so on, 79 times to get down to 1 molecule. Now the math involved, it's we haven't used it before. It's pre-calc. So some students will just divide it until they divide it by 2 until they get an answer. But the actual equation you have to use would look like this. So you could use that equation, or you could use this equation. This probably would make more sense to you all. No, actually. So this equation right here probably would be the one that would be easiest to use. But every time you cut it in half, you're going to divide this number by 1/2. And this exponent right here would be how many times you need to do that to get down to 1 molecule. So this would be the equation to use. Now, you haven't learned how to solve for an exponent, though, I don't think. You have to use log to do that. So I won't go through the math for that, but what you need to do would be solve for x right here. And when you do, x would equal 79, which would be how many cuts you would need to make to the pie to get 1 molecule. Okay, if there's no questions about the lesson, I'll just have you work on homework. It's on page 331. So do 19 and 20, A through C for 20, and then 21 and 26 and 27. I'll write it on here too so you can see it. So 19, 20, just A through C. 21, 26, and 27. And that starts on page 331.